different tests while doing your three-phase induction motor disconnect and reconnect. The first thing is to check that if anything is live. So how do you check that if anything is live? Your frame, your cables, how do you test it? From trusted earth. So where can you find a trusted earth closer to your motor? Using a socket outlet or power point. Or if you got a switchboard with a metal frame, you can also use the earth in the frame of the switchboard. Or if you find an earth stake very close to you, like obviously you will be using a trailing lead. If you find an earth stake, you can use that earth as a trusted earth as well. But in your motor disconnect reconnect exam, you have to show us that you will use that in a socket outlet, any socket outlet as a trusted earth. So I'm going to use that socket outlet there. But first I have to prove that the polarity of the power point is okay, isn't it?
Yeah.
So what I do is here, it's pretty easy. You select your meter into voltage AC settings, isn't it? Everybody knows that, AC settings. Yeah, so first thing is, so in the socket outlet in Australia is earth, active and neutral, isn't it? So what would I get if I measure the voltage between earth and active? 230. Active and earth, active. 240, 230, that's good, isn't it?
Yeah.
So what we don't want you guys to do is don't do that, okay? If you put it on your active and leave it like that, if your meter is faulty, most of these digital meters are like they got all protection, but if your meter is faulty, the other end can be live, okay? Don't do that, please. Always on your earth first and then your active, okay? Which one do you take out first?
Active.
Okay, thank you. And then what should I get if I go between earth and neutral?
0.
Thank you very much. 0, 0.3, that's nothing. And then you go between, which one first? Neutral or active?
Neutral.
Neutral and then active.
230.
230, 240, isn't it?
Yeah.
All good. So what you have is you've got a working power point, you've got a trusted earth. Why is that a trusted earth? Because that earth is running back to your switchboard in the earth link and the earth bar. And what do you have there? You've got a main earth literally going to the ground. How many meters below the ground? 1.2 meters, isn't it? So that's why you're using a reference point. Why is that? Because voltage is the potential difference between 2 points. And what is the voltage of this earth here? 0. And that's why you're using a 0 point to check anything. Okay. So use that reference point. And if you are testing the frame, just go to the frame wherever there is no paint. Okay. Like go on the actual metal. That's what I'm saying. Okay. On the screws position. What are you expecting?
0.
Everyone's looking at 0, isn't it? 0, a few points, 0, actual metal, 0, isn't it? And then what you do after that, after every test, what do you do?
Take a meter.
Test your meter again. How do we test our meter in voltage? Again measure a known voltage. My meter is still working, so if it's still working, it was working before as well. Okay, always check your meter. Prove, isn't it?
Every time you do a test.
Yeah, every time. Not literally every time, because if you're doing a combination test, you can do it at the end.
Yeah.
Okay. Now, if you are checking your cable, for example, or terminals, what you do is first use your trusted earth. Let's say these are the cables here, and then check all your cables against your trusted earth. Okay. Let's say these are your cable. Nothing. 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 Okay, you're expecting very low value, nothing. And then again, what do? Check your meter, okay, at the end. And then what also you have to do is, if you have written my notes, take it out, both of them, and go between the cable itself. Okay, go between the cable itself, face to face. 0 volt, A to B, A to C, and your B to C. And then you can also do single phase, earth to the phases, nothing, nothing, and nothing, but always finish off your test with testing your meter. 240 volt, the meter is still working. Okay, that's how you prove that anything is not live. Okay, before disconnecting and before reconnecting, isn't it? You have to do 2 times. Or before disconnecting, everything will be connected here. You have to check against the trusted and between them and before reconnecting, and then before disconnecting and as well before reconnecting. Okay, so that's the voltage test. And now testing the motor itself. Okay, just testing a 3-phase induction motor. if it's in a good condition. Okay. What is the first test we have to perform in a three-phase induction motor?
Continuity of the windings.
Continuity of the windings. How many windings are there in your three-phase motor?
Three.
Three, isn't it? Letter U, V, and W, and there are two ends of each winding: U1, U2, V1, V2, W1, W2. To do that test, your links has to be disconnected. Okay. Your links has to be disconnected because if you got a star winding, everything is a short, isn't it? Yeah. Make sure you disconnect your links, and then if you see here in this particular motor, every motor will be, if it's a good motor, it will be marked. It's marked here U1, V1, W1, and then it's always diagonal, isn't it? That's your U2, that's your V2, and your W2. Okay. So what settings do I use? Multimeter, ohms. Check the meter always. 0.1. I'm going from U1 to U2, getting 4.8 ohms. Okay, it's always good to do on your lug. Okay, lugs. V1 to V2, 4.8 ohms. W1 to W2. Check the meter. So what does it prove that? What does my test prove? It proves that all the windings are continuous from one end to the other end. Plus, this motor is a balanced load. Why is that? Because you got the same value for all of them, isn't it? Yeah. So that's why it has to be almost same. If you got one of them is 4.8, the other one is 3 ohms, that motor is no good. Okay, it has to be almost same. Okay, so once you've done your continuity of your windings, what is the next test you do on your motor?
Insulation resistance.
Insulation resistance test, IR test. Are you guys familiar with the this fluke meter? Okay. If you got your own IR tester, you can please bring that on that day. It's up to you. But this is a fluke meter here. So the first IR test I would perform is between the frame of the motor and the windings. Yeah. So what test will this?
500.
Why is that?
Single phase.
Single phase, double the nominal voltage. Okay. So how do you check your meter first? Okay. You have to always check your meter. You have to do an open circuit test and a short circuit test. Okay. Short circuit test. Put them together, only then press it, you're getting a 0, isn't it? Short circuit. Release the test button and then only taking out. Because what am I doing is I'm discharging as well. Put it together, test it, release the button, and then take it out. Let's do an open circuit test. Okay. At the moment when I press the test button, I'm putting 500 volt DC between these two probes. Okay. And this, the good thing with the fluke meter is it tells you how much voltage are you putting through. 526 volt DC, which is more than 500, which is good, isn't it? And what's the clearance am I getting? 550 mega ohms. Most of the fluke has a range of 550 mega ohms. If you got a different meter, you can have different range. Okay. So with your IR tester, the main thing is when I saw this, everybody understand that this is what your IR tester is doing. Okay. I'll put my meter into voltage DC. Can you please hold it? Okay. Can you please hold the probe? Okay. Just put it here. Okay. 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 DC, isn't it? DC voltage?
Yes.
Do it here. Yeah. When I do not press the button, it doesn't do anything. Look here, you're putting 0 volt. So to do your IR test, you have to actually press the button. Look here, how much voltage am I putting through?
520.
520, isn't it? 520, 526 volt DC. So that's the voltage that I'm putting through between those two things that I'm testing. Okay, so if you do your IR test like that, it doesn't mean anything. Okay, you have to actually press the test button. And the good thing with the fluke meters is, you guys know it, you've got a test button here, which is much safer rather than putting there and pressing the button here, isn't it? Yeah. So you've got your open circuit test. Let's do an open circuit test. You're putting 526 volt DC, which is more than 500 volt, which is good, and you're getting a clearance of 550 mega ohms. How much is mega?
Million.
10 to the power of 6. It's a very large value, million ohms. And what is the minimum requirement for your single phase?
1 mega.
1 mega. Okay, let's do it. Anywhere on the frame. That's a frame, isn't it? That's a frame and the winding. Okay, I can do it here or here. Isn't it the same thing?
Yeah.
Because they are continuous. Here or here is the continuous. Here or here. So I will do it on this side. Okay, I'll go on the log. Do it here. It's a very large value. Just let the voltage do its work. Don't do it very quickly. Okay, just let it do its work for a few seconds. Is that clear?
Yep.
Now discharge. How do you discharge? Keep it like that and release the test button for a few seconds and then move on to the second one. Still clear, very large value. Discharge. Third one. Discharge. Beautiful. Okay, you're getting a very large resistance, and at the end always check your meter. 0, discharge, open circuit, still good. Okay. So what does your IR test prove? Your IR test prove that the insulation between the winding and the frame of this motor is good enough, isn't it? Yeah. There's a adequate insulation between the winding and the frame. And then what else does your IR test prove? It proves that there is no short circuit between the winding and the frame. And when you actually connect your cable, if it can handle 500 volt DC, it can easily handle incoming 230. Okay. Now what's your second IR test?
Coil to coil.
Yeah, coil to coil, winding to winding. What's your voltage? 1000 volt DC. Okay. And then what's the minimum requirement?
10 mega.
10
10 mega. 10 mega. Let's test your meter again. Short circuit test. Especially when 1000 volt, make sure that you do your short circuit test properly. If you do it like that, if it's a hazardous area, you get a spark, isn't it? If it's a hazardous area, it can, create explosion. So that's why put it together. 0, discharge, and then take it out. And then let's do an open circuit test. How much voltage am I putting through? 1049 volt DC. What's the clearance there? 11 G. What do you mean by G?
Giga.
Giga. Thank you. So how much is giga?
Billion.
6.
Yeah, billion. Okay, 10 to the power of 9 billion ohms. Okay, mega is 10 to the power of 6. That's a very large value. Okay, let's go between the winding. I got my U here, V and W. Let's go between the winding. So I'm going to be U and V. That's a very large resistance. Okay, almost open circuit. Happy with that?
Yeah.
Discharge. With the other two, U and W. It's very large resistance. Discharge. Go between V and W. Thank you. Okay, that's good. And then here, again, do your short circuit test. Always testing your meter. Open circuit test. Okay. So what does it prove? It proves that the insulation between the winding is sufficient or good enough, and there is no short circuit between the windings, and the windings can easily handle the incoming 400 volt. Okay. So that's it. So that's the test you do on your motor. Continuity of the windings, IR between the winding and the frame, and IR between the windings. Okay, so those are the things you have to know. And then after that, what you do is normally you would connect the cables. And what is the final test you have to do before energizing your motor?
Continuity.
With that. No,
Yeah,
no.
test the earth continuity. Isn't it? What, out of these 4 cables here, 3 phase and earth, the most important cable is your earth, isn't it?
Yep.
That's a safety cable. But how do you know that this earth is any good? How can you prove that this earth is continuous back to your
With
switchboard?
your known source.
Yeah, it's because that trusted earth, we know that it's going back to the earth bar, and if that earth is any good, that earth also must go back to the earth bar, isn't it? So what you do is multimeter, ohms, isn't it? Ohms, multimeter. Always check your meter, okay, and go from the trusted earth, okay, to your frame, isn't it? At the moment it's not connected, you will not get any value, but if it was actual in the real world, what value are you looking for?
0.5.
Less than 2
Very
ohms.
low value, less than 2 ohms. Why did I say less than 2 ohms? Because you're adding so many things. You're adding the resistance of the extension lead, you are adding the resistance of RE of that circuit, and this circuit. You're adding so many things, okay? But if you want to get exactly for the motor, how do you do it? You subtract this, subtract the resistance of the earth for that PowerPoint circuit, and then you would only get for this circuit here. And how do you check that value? Table 8.2, column RE. Okay, that's how you do it. Okay, those are the tests you have to remember. Okay. So what do we do? Voltage test with the trusted earth, winding continuity, IR single phase, IR 3 phase, and your earth continuity. Anything that you disconnect, reconnect, you always have to do your earth continuity check. Not only with the motor, any appliance you disconnect, reconnect, because what do we have to do once we finish our work? CCEW. So it's a requirement that you have to do your earth continuity once you do any disconnect, reconnect. Okay, and then one more thing, all of you are here. So once you put the cover and then once you energize everything, how do you check the rotation using that control circuit there?
Just quick stop.
Quick stop.
Stop.
Okay, don't forget that. And how do we fix the rotation if it's going the wrong way?
Change phase.
Swap in 2 phases, just here. Okay. So normally it's red and white, U and V. What you can do is you can change here, white and red like that. Your motor will spin the other way. Okay? Yeah, that's it. Those are the things you have to do. And then obviously please bring your completed JSA. Completed JSA. And then like when you leave the site, how do you make those cables safe? What
Put
did
them
you
into a JB and keep them off the ground.
take a picture before? Always disconnect your earth last. Isn't it? Always disconnect your earth last. Put it on connectors or put it on tape in a junction box off the floor. Okay, those are the things that has to be there in your GSA.
Yeah.
All good?
Yeah.
Any questions? No. Okay. So if you got your own IR tester, please bring your own IR tester. I'll show you how to use that. Okay, you